Hello, my name is Andrew Choga, and this is my honeypot detection project using AWS as the virtual machine where the instance is created, and T-Pot is our open source software where we'll actually be using the honeypots from. Okay, so a brief overview. This is a GitHub I created. I will link it at the bottom of the video there in the description. So, feel free to take a look. Um, you create the honeypot with AWS, just create an instance, spin it up, um, launch it, and connect via SSH with your instance key. Don't forget your key pair. That's very important. And remember where you download your key pair too. And then just use the git clone to actually install Teapot. After that, you reboot and then just set these parameters in your security group and firewall. This should allow you to receive traffic or information from your attackers. Then just connect to a port. Use the web interface to port 64297. Okay, so what is a teapot? No, sorry, what is a honeypot? A honeypot just it's basically a software that mimics vulnerable systems. So, if someone wants to hack a medical institution, they can spin up a honeypot, simulating like very valuable data that people want, right? And then all we do is track how people gain access to that data and find a way to prevent them from doing it in the future. You know, kind of like a test field kind of thing. Yeah, once you've actually set up the honeypot, you should be able to see a page like this. But after this, you got to sign in. During the installation process, there's definitely going to be a sign in page at some point. But yeah, after that, you'll be able to get to this page. Then you can explore all these things here, these analysis tools. But we're gonna use CyberChef today. I don't really use these other ones, but CyberChef is pretty cool. Gonna use it, and this is an attack map I did before because I had been spinning this honeypot for like a week or two, give or take. So through my analysis, this is all I came up with. I mean, you could just check out the GitHub. You'll see it for yourself. Like for example, 185 attempts in the last 1 hour. Just imagine. And 29,252 in the last 24 hours. Yep. It shows you countries that attack the most and all the insights you can get from it too. Um, then there's the teapot dashboard, which is in Kibana. Yeah, there's a teapot, honeypot, which basically shows you all the information of all the honeypots. So yeah, you can see like which kind of data people were trying to get the most, what kind of OS they've been using, the countries that attack the most, if they're known attackers or mass scanners or bots, all the good stuff. Most used passwords and usernames, Rocky.txt, if you know, right? And there's the Cowrie dashboard, which is mainly for SSH and telnet attacks, brute force attacks basically. But lot of information, a lot of information. I'll I'll show you how I'll do a little some of these in a bit. So yeah, that is the GitHub. Let me show you the actual honeypot environment, Teapot environment, sorry. So for the attack map, I've already opened them up just so it's easier for me to explain. So for the attack map, here's the attack map. As you can see already, the most number of hits we've got is 104 from the United States alone, which means United States is our um, highest country for the day. But we've got already 195 in the last 1 hour and 24,511 in the last 24 hours. And over here, you can see the honeypots, the type of attacks they were trying to use. So there's a honeypot called Honey Trap, and It simulates valuable data too, and they were trying to get into that. And it also shows the service here. Each color on the map actually means something. So, you can take a look over here. And just by looking, you can see over here that this person was trying to do a DNS intrusion, infiltration type thing. And look, check this out. This guy is a known attacker. And his IP is in some kind of system, and we know that this guy, he does this a lot. That's what that means. And I'm pretty sure I showed before. This is teapot, the teapot one, the one with all the honeypots. So yeah, it shows that we've had 11,468 attacks, only Cowrie. So these are brute force attacks. 11,000. And this is just in the last 24 hours. And it refreshes every minute. You can change this to whatever you want. But yeah, these are all the most used passwords and most used usernames, the IPs that have been attacking the most, all that stuff. And yeah, it even shows like the countries that have been attacking the most. Where are you at? Okay, over here, Canada, most. Just a matter. Actually, that may have been me. Actually, I'm thinking about it. That was probably me from last night. Uh, yeah, that was probably me. Mostly known attackers attacking here. So, people whose IPs have been on some kind of list that these guys attack a lot. And mass scanners as well, and bots. Core exit node. Ooh, you're in browser people, huh? Okay. Dark web stuff, if you know. Anyway, let's go to the Cowrie dashboard. This one's actually pretty cool. Lots of data, lots of info here. See, attacks, 11,000, over 11,000 attacks, and 61 of them unique source IPs. These are unique IPs, mostly SSH attacks. Go figure. Because of me, once again. This is my fault. This last night, I I did something, but yeah, this is from last night. SSH, yeah. Most used passwords. This is all in the last 24 hours, by the way. So yeah, most used passwords, most used usernames, and you know, these are the top 10 inputs. You know what? Let's change this. It's not enough. Let's say 7 days. Last 7 days. Yeah, there you go. There you go. There's a whole lot more. This looks a little bit better too. Um, yeah, this is what we got over here. But during my analysis, on this list over here, sometimes you see some really fishy stuff, some stuff that you're like, yo, what is this? And then you just want to go and research, right? So there's a discover page in Kibana, and you can do a little bit of some exploration. You can go explore. So using KQL, which is the Kibana query language, I think, something like that, you can put down these parameters like type keyword, Cowrie, input exists, and then you can put IP that you want to target. So I saw this specifically. I saw this on that top 10 list of commands, and I thought, yo, what could this possibly be? I've never seen anything look like this before. And I went, started researching, and I saw that, okay, let's start from the beginning on the timeline here. So this guy um, basically targeted and created a file in the TMP, right? Created a file in TMP, and then he went to the directory, right? He went straight to the TMP, and then he changed the parameters of the file he created to executable, right? So as he wants to run something, clearly use bash C, blah 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 blah, whatever. But he created a file that he wanted to run in our system. Okay, cool. And then he ran it twice. He ran it twice, probably just to make sure that it actually ran. But yeah, this is definitely malware. There's no question about it. This is malware. Now say you're busy with something else, or you got something more important happening right now, and you managed to come across this. You can just go ahead and click share and then CSV report, and you can download the CSV like I did over here, right here. And if you want confirmation or anything, I think you can just let's copy all these. Let's take everything here and let's just copy it. And we're gonna put it in ChatGPT. Sometimes you need confirmation, right? That's ChatGPT. Oh, wait, didn't even copy. Let's copy this and paste it in ChatGPT. Yeah, let's see what's happening here. Yep, definitely taking its time. Oh, the file is in TMP, is being made executable. Yeah, and then attempted to execute. Yeah, see? What else? Cannot be found, could not be executed, possibly due to permissions. So probably his chmod didn't go through properly. Does not exist in the location. But yeah, definitely potentially malicious, yeah, malware for sure. Yep. This guy tried to create a malware in our system, tried to run it. Knows if it succeeded. Probably didn't. Anyway, that's just an example of how you can do this research. Again, there's also Suricata. This is also for this is also like it tracks down brute force attacks too, or more specifically, it monitors network traffic for malicious activity. So, for example, the payload here, we can see that this guy tried to get to the root website, right? And try to access our port. By the way, our port over here. See that? That's the one for our honeypot. 3.133.96.177. And if we go back to the Cicada thing, that's the one that he tried to access, try to get into it. And try to curl the curl, this is the version he tried to use. He's using he attempted an information leak. See, you can get all this info and put it down just for later analysis too. You don't have to do everything at once. Later analysis, save it, and you can do your own research later. Now, for this year, it's not like every time you'll get like the payload printable. Sometimes all you get is this payload, and you have nothing to do with it. Now I know this is base 64, right? You can come to CyberChef here and just try a bunch of different things. So I'm just gonna do uh from base 64. Not from base 64 should work, but yeah, it'll give you this. See that? And that's exactly what we have over here. There's some pretty cool stuff. You can get their IP, the IP of the person who tried to attack you. This is their real IP, by the way. The IP of the person who tried to attack you, the time that they attacked, and look at this. In Ohio, Columbus, United States. That's where they're from. You could get a lot more specific, trust me. You could get their postal code and everything, but you know, I'm a kind person. But yeah, back to the Cowrie thing, I forgot to show you like the timestamps over here. Look at this. Look at this. The time difference between this and this is literally milliseconds. Look at that. Look at that. To type all this, no. Either a script or a bot, but definitely a script. It's probably a script. Look at this. Look at this. 10 milliseconds have passed. No, less than even. Look at that. That's crazy. Anyway, now let's say, okay, yeah, I did this on purpose for the last 15 minutes and nothing should be there. Good. This is a Kari and SSH attack. So we're going to simulate an SSH attack right now. This is just to, for example, if you have all these different things and you don't know if or if you don't know if your honeypot is running properly or your teapot, I'm gonna use this guy right here, Kali Linux, whatever you want. Uh, I'm gonna use Hydra, right? Okay, but before we even do that, Rocky.txt, right? This is a text file with as you can see here, over 14 million unique passwords used in over 32 million accounts, right? So these passwords, they're most used. Now we're going to use Hydra, which is used for brute force attacks. We're going to use Hydra. Right. Now, the service we're attacking is SSH because we're using Cowrie over here. And I said before, SSH or Telnet. So let's use SSH, right? And the file name, which is just the guy, the dude who we're trying to attack, right? So which is us. So that's 3.133.96.177. Okay. And the username to text or file name. See, I've already downloaded the rocku.txt file into my home directory. So we're just going to do that. Rocku.txt. That's the one we're going to use. And for the password, we'll do the same thing. Rocku.txt. Blah, 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 blah. For these, we're just going to leave them empty. We've already done basically what we needed to do. So I'm going to leave this empty. Port number, we wouldn't know, right? Like, let's assume that we don't know what the port number is because, well, likely we don't know. But so let's do that. We're going to leave this empty too. Yeah, we want to continue. And let's see what happens here. Yeah. Come on, buddy. Oh, look at that. We have a password here, a login, username and password. I love you is our username. And the password is 123456. Okay, that's pretty cool. Now that we've done that, let's refresh and see if we got anything here. And boom, this is us. By the way, I forgot to mention I'm in Sudbury, Ontario, right? Sudbury, Ontario. Just to look at that. See, this is us. Sudbury, Ontario, blah, 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 blah. All the good stuff. All the good things. They're over here. Let's just put that. No, don't need that. City, country. Let's put the region name too. Ontario. I wonder if we got an input. No, no input. But I mean, that's okay too. So as you can see here, look at these. And I bet there's a lot of them. Because you don't just happen when you run Hydra, you don't just happen on the password, right? It's running many different passwords at the same time until it gets like the right variation of passwords, right? And username. So, there's probably a whole lot, it's probably a lot of pages. Look, 5 pages. 5 pages just for me. Just for me. 5 pages just for me. So yeah, you can try this on your own if you want. The honeypot is there for you to use. And yeah, that is my project. Thank you.